Hello friends, welcome to Susan and John MathTube. In today's video, we're going to continue our discussion in normal distribution. In the last video, I gave you a general introduction to the normal distribution and the standard normal distribution. And in today's video, we're going to do a lot of problems based on normal distribution. So be ready with your pen and paper, and one more thing, a very important thing, your statistical tables. Okay, so let's start. The normal distribution is a special case of the continuous distribution, and it is related to many things which is happening around us, and that's why the word normal. We discussed a few examples. Anyway, a normal distribution generally looks like this, that is in the shape of a bell. In continuous distributions, finding probability is actually integration. We learned that long back when we learned about continuous probability distributions. And the probability distribution functions are always positive, so they are always above the x-axis. And when a graph is above the x-axis, then integration stands for area below the curve. Integration is basically continuous addition, but when the graph is completely above the x-axis, integration will be exactly the area. So probability implies integration, and integration implies area. So in your statistical tables, you will see a lot of numbers given under the table standard normal distribution. Now look at this. The standard normal distribution is a normal distribution which is symmetric about the y-axis. Half the distribution will be on the negative side and half will be on the positive side. And of course, as always, the total area of the graph is equal to 1. And then the graph becomes asymptotic to the x-axis, and on this side it goes to infinity, and on this side it goes to minus infinity. And if you look at the standard table, let's say you'll see values like, I have the standard tables which is provided in your exam in my hands. So if you look at the positive scores, then you'll see something like Z, then 0.0, 0.1, 0.2, and over here you'll see 0.00, 0.01, 0.02, etc. So suppose you want to find the value 1.17 in your table. All you have to do is you have to go down and find 1.1 and then move in this direction, and move in this direction so that you will reach 0.07, and this particular value where this 1.1 and 0.07 meets will give you capital F of 1.17. I hope you remember our capital F. Capital F stands for our cumulative distribution function. That means the area from minus infinity to 1.17, that is the area from minus infinity to 1.17 in the standard normal graph will be equal to the value you just found. At the same time, if you are interested in minus 2.32, so the first thing you have to do is you have to take negative set scores. That is the first page, and you'll be able to see the values of Z over here. It starts from minus 3.4 and you go down till you see minus 2.3. and you move in this direction so that you are able to coincide with 0.02. You'll be able to see 0.01, and this particular value will be capital F of minus 2.32. That is the area from minus infinity to the point minus 2.32. Okay, we'll be going through that a little bit later. Anyway, once more I'll repeat what I told in the last video. Suppose x is a variable which follows the normal distribution with mean mu and standard deviation sigma or variance sigma square, then the transformation x minus mu by sigma, which I'm going to call as z, will follow the normal distribution with mu equal to 0 and standard deviation equal to 1 or variance is equal to 1. This is called the standard normal distribution. So that means given any experiment which follows normal distribution, it can be converted into the standard normal distribution. And once you convert it into the standard normal distribution, you will be able to calculate the probability values, because probability values is equal to the area under the graph. And the area under the graph with an accuracy of 2 decimals is provided in your table. Okay, having said that, let's check out one problem so that you understand the concept properly. So be ready with a pen, paper, the statistical tables, and one more thing, a calculator. So shall we start? So look at this. We have a question which was asked in 2074. So it's given that the breakdown voltage of a diode is known to be normally distributed, and the mean is given, and be very careful with this, the variance is given. So it is not sigma, but sigma square is given to be 2.25, and that means sigma will be 1.5. Just take the square root, is 1.5. Now clearly this is not the standard normal distribution. Standard normal distribution means mu will be 0 and sigma will be 1. Is it 0? No. Is this 1? No. So this is not the standard normal distribution. Okay. So what we do is, let's call the breakdown voltage to be capital X. So you can note like this. Let capital X be the continuous random variable associated with the breakdown voltage. If a randomly chosen diode, it's already given its capital X. So capital X follows normal distribution. Look at this. Some books follow the notation mu sigma and some others follow the notation mu sigma square. So if you don't want to make anyone confused, it is better to write X follows normal distribution with mu is equal to 40, and if you wish to write sigma, you write sigma. If you wish to write sigma square, you write sigma square. This is a better notation. Don't put it like 40 comma 2.25 so that people will get confused. It's always better to be more clear. Anyway, I'm going to write sigma because to transform we need sigma, not sigma square. Okay, the next line, we are going to convert this into the standard normal so that we can use the table. So we are going to write, we know that z equal to x minus mu, the whole divided by sigma, follows the standard normal distribution. This is a notation for standard normal distribution. This means mean is equal to 0 and variance is equal to 1. In the first part, they are asking what is the probability? What is the probability the breakdown voltage, that is capital X, will be between 39 and 42? That is, we are interested in the probability that breakdown voltage, which we denoted by X, is between 39 and 42. So this is the mathematical equivalent. Probability the breakdown voltage lies between 39 and 42. Okay, now what I do is I am going to standardize this. When you learned inequations long back, maybe in class 11, you have learned that you can subtract an inequation throughout by any number you like. So I am going to subtract throughout by mu. And you are allowed to divide by any positive quantity so that the inequation will not get reversed. So I am going to divide throughout by sigma. Sigma being standard deviation whose formula comes inside a square root, cannot be negative. So you are allowed to divide by sigma. Now I'll repeat once more. 1 minute back we wrote Z equal to X minus mu by sigma follows the standard normal distribution. That means once you transform capital X into this format, you are allowed to use the standard normal distribution table. Okay, so I am going to substitute the values. Probability of 39 minus, what is mu? Yeah, 40. Divided by, where is our sigma? 1.5. What do you call this? Yeah, it's called Z or C. You can call whatever you like. So 42 minus 40 divided by 1.5. Take a calculator and simplify this. So we get probability of minus 0.67 less than Z less than 1.33. Okay, now we have to discuss a few things. Look at this. This is our standard normal graph. And I hope you're ready with the tables. Suppose we want probability of Z less than, let's say, 1.67. So what you do is, you can mark this region. This is 1.67. It's a rough graph. And Z less than 1.67 means this is the required area. And from the table, we get capital F of 1.67. I told you how to find this. And capital F means the area from minus infinity to the number you mention inside the bracket. So this is actually capital F of 1.67. Now suppose our question is find probability of Z greater than 1.67. Now we have a problem. Look at this. We have the standard normal graph. And let's say this is 1.67. And this time you are interested in this area. But sadly, your table always provides the area from minus infinity to 1.67. So it's very easy. All you have to do is you have to do 1 minus, because the total area of the graph is 1 unit. The total area of the graph is 1 unit. So this is 1 minus probability of Z less than or equal to 1.67, or this is 1 minus capital f of 1.67. I hope you got the point, because the graph provides this area. So if you want this side, all you have to do is 1 minus this part. Okay, now a third possibility. Suppose you want the area between, let's say, A and B. So this is the what you call the required area. From the table, you'll be able to find f of b. Now let's check what is f of b. F of b means the area from minus infinity to b, this much. Now f of a means the area from minus infinity to the point A. So that will be this. So what will be the area between? Suppose you want A less than Z less than B. A less than Z less than B means the area between A and B. So all you have to do is you have to find f of B minus f of A, which is available in our table. So I hope you understood this logic. F of B means the area from minus infinity till B, and f of A means the area from minus infinity till A. So if you subtract the bigger one and the smaller one, you're going to get the area in between. So we had 3 cases. So let's go back to our question. So look at this. We want the probability that Z lies between minus 0.67 and 1.33. So graphically, we want the area between minus 0.67. Let's say this is minus 0.67 and 1.33. So this is the required area. And from the tables, you can find 1.33. So take your tables. I told you how to find the value from the tables. It's a positive value, so turn the positive Z scores and go down till you see 1.3. And here you'll be able to see 0, 0, 0.01, 0.02, 0.03. So make sure you coincide this and this, okay? And the value is 0.9082. And now you can take the negative table and find 0.67, negative 0.67. That means you find minus 0.6, and here you find 0.07 and take the coinciding value, that is actually 0.2514. So you know what to do now. Capital F of 1.33 minus capital F of minus 0.67. So if you want the value in between, all you have to do is find the cumulated value till 1.33. That means you will get this much area, and then you find capital F of this one, so you will get this much area. So the area in between will be the difference, and that is equal to 0.6568. Okay, so let's move ahead. So now let's go for the second part. So in the second part, they are asking, what is the probability? Okay, so I'm going to write the probability that the breakdown voltage, that is capital X, is less than 44. So what we do is very simple. We're going to standardize this. So we had the prior information. It follows mu is 40 and sigma equal to 1.5. Okay, so how do you standardize it? First, subtract mu on both sides. Then divide by the positive quantity sigma. So you get probability of Z less than 44 minus 40 by 1.5. So take a calculator, and that is 2.67. Now draw the graph. And this is what we want. Let's say this is 2.67. So we are interested in this area because less than 2.67 means minus infinity 2. So take your tables, find f of 2.67. And what does f of 2.67 imply? Or what is the meaning of f of 2.67? Area from minus infinity to 2.67, which is exactly what we want. And from the table, the value is 0.9962. Now let's go to the third part. So in the third part, they're asking what is the probability the breakdown voltage is more than 43. So just like the second part, I'm going to write probability the breakdown voltage, which we denoted by X, is greater than 43. Look at this, when you have the sign greater than, immediately convert it into less than or equal to by using this property. And the next thing to do, standardize it. How do you standardize it? Just do minus mu by sigma. That will be, now I'm going to substitute the values. Minus mu means 40 and sigma is 1.5. It's less than or equal to. So I'm going to get 1 minus probability of Z less than or equal to 2. Now that is equal to 1 minus capital F of 2. Look at this. This is 2, and if you want the probability of Z less than 2, you're actually talking about this side, because less than 2 means it can be anywhere from minus infinity to 2, and that is exactly what is given by capital F of 2 from the tables. And you can check the values, simplify. The final answer is 0.0228. I hope you're okay with the problem. Let's do a few more problems from your past year's question paper. So here we go. Another question from 2074 Chaitra. Okay, so let's start. So here they are talking about the life of an electric bulb, and it is given that follows normal distribution with mean 800 hours and standard deviation. Please note it, they have not given the variance, they have given the standard deviation. And they're asking you to calculate the probability. The life will be between some numbers greater than some numbers. So let's start. So let capital X be the continuous random variable associated with the life of electric bulb. Given that capital X follows normal distribution with mu equal to 800 and standard deviation equal to 50. Clearly this is not the standard normal distribution, because standard normal distribution means mu will be 0 and sigma will be equal to 1. Okay, now we write our famous line. We know that Z equal to X minus mu the whole divided by sigma follows N01. And what do you mean by N01? The standard normal distribution. That just implies we are allowed to use the statistical table, and that means we are allowed to use the standard normal distribution table. Now let's go for the first part. What is the probability the bulb burns? Okay, so I'll put it in mathematical form. What is the probability the life of bulb we denoted by x between 750 and 825? In the first problem itself we saw how to write this between condition. This means x is between 750 and 825. Now what to do next? Exactly, we have to standardize this. So we do our old trick, 750 minus mu less than x minus mu less than 825 minus mu, and then divide by sigma by sigma by sigma, and this is denoted by Z or C, whatever you like to call, and let's plug in those values. Use your calculator, and I got minus 1 less than Z less than 0.5. That means we want the probability between minus 1 and 0.5. So from the tables you find f of 0.5. And what do you mean by capital F of 0.5? The area from minus infinity to 0.5 under the graph. And what do you mean by f of minus 1? The area from minus infinity to minus 1. So the answer is capital F of 0.5 minus f of minus 1, and you're supposed to get 0.5328. If you get the answer, please comment below. Okay, now let's go for the second part. Okay, so the second part is find the probability the bulb burns. Okay, so let's write probability the bulb burns, the life of the bulb is more than 900. Now I'm pretty sure that you know what to do. Greater than, I hate that greater than, so I'm going to put it as less than or equal to 900, and x is not standard, so I'm going to standardize it by x minus mu by sigma. That will be 900 minus mu by sigma, and we already know it's in the last page. Mu is 800 and sigma is 50, and when we plug in all these values we get 1 minus probability of Z less than or equal to 2, because 900 minus 800, that is 100, 100 by 50, that is 2, and this is 1 minus capital F of 2, because this implies the area from minus infinity to 2. So this is that area, and use your statistical tables and make sure you get the answer 1 minus 0.9772, and that is equal to 0.0228. Now let's check one more problem, which is a slightly different type. So this is a question from long back, 2007D. So read the question. The mark obtained by an IOE student in statistics. The mean mark is 50 and variance is 16. Please note they are not given the standard deviation, so it's a warning. Please be very careful. If 5,000 students have given the exam, find the probability. No, they didn't ask find the probability. Okay, so that is why I said it's slightly different. Here they are asking the number of students. So look at this. So what we do is we will find the probability. Even though they didn't tell you, find the probability. And finally, we will multiply our answer with 5,000. So that's exactly our plan. So let's start. So how do you start? Let capital X be the continuous random variable associated with marks obtained by IOE student dot dot dot. It is given that capital X follows normal distribution with mu is equal to 50 and sigma square is equal to 16, because it's given variance equal to 16. So sigma will be equal to 4. And our famous line, we know that x minus mu by sigma, which we denote by Z or C, whatever, follows the standard normal distribution. And for the first part, we will calculate the probability of x being less than 40. And that will be equal to probability of x minus mu by sigma less than 40 minus mu is 50 and sigma is 4. And that will be probability of Z less than negative, and 10 by 4 will be 5 by 2 will be 2.5. And from the table, this is actually capital F of minus 2.5, and that is equal to 0.0062. But this is not the answer, because they didn't ask probability. They didn't ask probability, they asked the number of students. So you have to write, therefore, the number of students is equal to 5,000, because total 5,000 students attended the exam, multiplied by 0.0062. And use a calculator. So 5,000 into 0.0062, that gives me a very good number. I never expected that. That is 31. Okay, so we are expecting just 31 students to score marks less than 40. Yeah, now the next question. Okay, here we want the number of students securing marks between 35 to 60. So what do we do first? Okay, so first we find the probability the marks lies between 35 and 60. And you standardize it, 35 minus mu by sigma, which is 4, less than Z less than 60 minus mu by sigma, and that will be probability of minus 15 by 4, 3.75, less than 60 minus 50, division 4, that will give me 2.5. So we are interested in the area from minus 3.75, our origin 2.5. So they are interested in this much area, and from the table you find f of 2.5. In which table? Yeah, positive table. 2.5. What's the value? 0.9938. And now in the negative table, can you spot minus 3.75? I think this value is missing in the table. No. That is what many students think. I wanted to take the negative table, negative set scores, and read the note which is given beneath the table. What is it given? For values of Z below minus 3.49, what are we supposed to write? 0.0001. Okay, so please be aware of such values, and whenever you are provided with a table, you are supposed to read from the top till the bottom. So the answer will be 0.9938 minus 0.0001, that will be 0.9937. But did they ask you probability? Of course not. They asked you the number of students. So we multiply 0.9937 with the total number of students who appeared in the exam, and that will be, use a calculator, 0.9937 multiplied by 5,000, 4,968.5. But the number of students cannot be decimal, so it is like 4,968, or you can write 69 as you wish. Now I'll show you a few more questions, but I'm not going to do those questions right now. Yes, you're going to do these questions just after the video ends. Okay, so this was asked pretty long back, 2069. That doesn't mean they won't repeat it. Okay, so define standard normal distribution with area property that we discussed in the last video. And here they are talking about the length of life of dry cell. So they have given the mean, and it is given that the length is normally distributed. So like the last question, they are asking the number of batteries. So what you do is you find the probability and then multiply by 600. So you can try it, and if you have any doubt, you can contact me in our website www.sjmathtube.com, or you can put a comment under the video. Okay, now one more question. That's from 2070. Here they're asking probability. Okay, so this is about assembling a piece of machinery, and it is given that the assembly time is normally distributed. So you can try these questions, and I'll be back soon. Next video will be the last video in normal distribution, and in that video we'll be talking about the inverse normal probabilities. Of course, in such problems, the probability values will be given. This will be given, and we are going to find the quantity over here. So I'll be back soon. Till then, bye.